Hello, everyone. You are all welcome to another seminar session of Fixed Point Theory and Applications Research Group. Today, we are presenting our group work titled Fractional Order HIV/AIDS Infection Model with Caputo-Fabrizia Fractional Derivative. The members of the group are Awal, Adamu, and Kanitin. The outlines of our talks is as follows: introduction of fractional calculus, elementary definitions, introduction of HIV/AIDS infection, model description, numerical analysis, which is still working on, which is not present in the following slide. And we end up by showing some references. I will be the first speaker. My name is Awal Hamis Usman. At the beginning of 17th century, Newton and Leibniz discovered calculus, where each one independently made the foundation for the first time. The popular notation used in calculus given as this, which shows that D is a derivative of order P, where P is a non-negative integer of a function U of T, where T is the independent variable, which is popularly used in this field. Concept of fractional calculus started when equations raised by L'Hopital in his letter sent to Leibniz, asking what will be the half derivative of a function. When the Leibniz respond to the L'Hopital, he pointed out by saying it is a contradictory to common sense, but it may be drawn as a useful consequences some days. So later, his paradox statement comes into existence, which led to the foundation of the fractional calculus, which nowadays we are seeing the application of fractional calculus in various fields of science. Elementary definitions. Here we are trying to give the basic requirement which we may be required in the following research. The first one is differential equation. As we all know, differential equation is an equation involving derivatives with respect to one or more independent variable of a function or functions. So the differential equation is said to be ordinary when the function depends on a single variable, while it is partial when the unknown function depends on two or more variables. So order of derivative, which is defined as the highest derivative, appears in the given differential equation. So since we introduced, but we know that calculus comprises of two things, differential calculus and the integral calculus. So here we are trying to present some basic terms of fractional calculus. So fractional calculus, which is defined as the study of derivatives and the integrals of an arbitrary order. So the difference between fractional calculus and classical calculus is that the order in fractional calculus is arbitrary. That is a positive real number which is not integer, while in classical, they are only considering a point that is a positive integer as the order of the derivative. Gamma function, which is a popular function, is a popular integral given by the following and denoted by gamma of alpha, given as this, where alpha, to make this integral meaningful, this has to be greater than 0. So when a double integral formula is applied to this, then we can derive a following recurrence relation, which is very useful. Also, beta function is a popular integral given by this relation. And also, if we apply integral by part and gamma function, the recurrence relation previously presented, we can be able to derive a recurrence relation of a beta function given in terms of gamma function. Repeated integral. Here, when we have a function defined in a certain interval from 0 to x, we call this indefinite integral. So this indefinite integral is defined by this. So as we all know, we can integrate a function more than once when it is integrable within the domain. So to find a second integral of this function, we need to integrate this again. So continuously like this, you can have a multiple number of integrals. So if you continuously integrating within the domain, we'll be able to have what we call a repeated integrals. Cauchy result. Cauchy result, look at this indefinite integral or repeated integral to generalize or to come up with a very good result, which presented as this. Fractional integral. Fractional integral of order alpha greater than 0 for a function f from r positive to r is defined by this relation. So where the order alpha is an arbitrary, so is given by this. So it looks like a convolution function, which they have some certain relationship with the convolution function. Convolution function, which is also defined in terms of integral term. So this definition is similar to the Cauchy result. So Caputo's definition of fractional derivative is given by this. So now we are trying to define a fractional derivative. Is defined by this, which says that to find a fractional derivative of order alpha, where alpha belongs to the interval n minus 1, and where n is a natural number, for a function f of t is given by this. This shows that the fractional integral defined as this, while this is defined a classical derivative of a function of order n, as we know that n is a positive integer. So Caputo-Progressia derivative setting is given by this, where it says that define a pi function in a Hilbert space H1 be greater than alpha and greater than beta, where alpha beta belongs to an interval 0, 1. Then the new fractional order in Caputo derivative sense is recalled as this, where the normalization function is given by m of beta with a certain properties need to be satisfied. But if, should in case the function doesn't belong to this space, then the derivative can be reformulated given as this. Sumudo transformation. Sumudo transformation is a transformation criteria where it transforms a function. So it defines by given a set A of a function, set of a function A equals to pi of t, such that there exists this with a condition t belongs to this interval. So the transformation is defined by this. So Sumudo transformation of Caputo derivatives, when we apply this transformation to Caputo derivatives, then we will be able to have a relation given here. And also Sumudo transformation of Caputo-Fabrizia derivatives of a function pi of t is given by this. So here we are trying to show the behavior of the function in a graph. So if we take the blue line, which is the original function, which is a straight line, and if we differentiate, as we know that the derivative will be constant, which is 1, is given by a constant line, straight line, constant straight line. And also the derivative, the integral of this function is given by this curve. So now if we want to see how the half derivatives of this function is given, so we show in the next graph, that is derivative and the fractional derivative of x of order half. So which is given by this pink line, as you see. The shape at the integral, and it looks like a negative of the order. So now this is where I will stop, and the next speaker will take over. Thank you.
Okay, next we will talk about the medical model. The medical model describes behavior of real-life system or phenomena, whether physical, psychology, or even biological. Then every mathematical model is based on content assumption. Then the model may be in the form of the ODE, PDE, or the integral equation. The next we focus on the modeling infection disease. Example, disease where the individuals are infected by pathogen, microorganisms, right, and for instance virus and bacteria, fungi, and microparasites. Okay, the transmission of the communicable disease in a population usually depend on the A, the susceptible individual, and B, the exposed individual, and C, the infection individual, and D, the recover or remove individual, and the last is the mode of transmission of disease. Then transmission is of two types. The first, horizontal transmission and vertical transmission. SIR model is the name of susceptible, exposed, infection, and remove. SIR model are the approaches for the disease transmission when infected people go through a delayed period. It means infected but not yet infected. Before becoming infection, there include such human disease, rubella, and hepatitis B, and most notable the AIDS. The total host population in the name of N of T is the patient into 4 compartments with first susceptible and exposed, infection and remove, then the site of SEIR. The next we introduce the HIV and AIDS. AIDS is the name of acquired immune deficiency syndrome. The name of AIDS has developed into a global pandemic since the first patterns were identified in the 1981. The human immune deficiency virus HIV is a lentivirus that causes AIDS. This serious disease destroys the immune system of the human being, which produces teething opportunist infection in the body. It is reported that 38.6 million people currently live with the HIV and AIDS infection, and 4.1 million people has been newly infected, and 2.8 million AIDS deaths. HIV is transmitted through bodily fluid that include the first blood, and the second the semen, and the three the vagina and rectal fluid, and the fourth is the breast milk. The symptoms of HIV and AIDS vary depending on the phase of the infection. The primary infection includes HIV. Some people infected by the HIV develop a flu-like illness within 2 to 4 weeks after the virus into the body. The first, fever and headache. The second, muscle and joint pain. And the next, sore throat and painful mouth sore. And the next, delirium and weight loss, and cold and night sweats. And the last, swollen hands and mainly on the neck. The clinical range infection chronic HIV. In the state of the infection, the HIV is still present in the body and the white blood cell. However, many people may not have any symptom or the infection during this time. This state can last for many years if you are not receive antiretroviral therapy ART. Then some people develop more disease much sooner. The symptomatic HIV infection, as the virus continue to multiply and destroy your immune cell. The first, fever, and the second, swollen lymph nodes, often one of the first signs of HIV infection, and the next, diarrhea and weight loss, and oral infection, and the last phenomena HIV virus, and the second from mother to fetus, and the next blood transfusion and sexual transmission. Then we get the classical order model of HIV and AIDS improvised the Professor Charlie Goss and Cruz 2009 and given by equation 1 by division of ds by dt, di by dt, dj by dt, and da by dt. From the equation 1, we consider the model discussed in Professor Chai et al. In 2009. Be talking the KMUTTFactional derivative of the system or from equation 1 to equation 2 in the form of KMUTTFactional differential equation. So we get the parameter and the compartment S, I, J, A. S is a number of susceptible individuals, and I is a number of asymptomatic place individual, and J is a symptomatic place individual, and A is a full brown AIDS group. And the mu K is a recruitment rate, and mu is a natural death rate, and C is a number of contact of the individual per unit time, and beta is a disease transmission per contact first state, and B beta is a disease transmission. In the next parameter K1 is a transfer rate of the asymptomatic, and K2 is the transfer rate of the symptomatic, and alpha is the treatment rate, and D is a disease related date. So the aim of this section is to provide a special solution of the system by applying the Samudu transfer on both sides of the all equation altogether with a iteration method to get the equation. Apply the Samudu transform on the both sides of the proposed model. We will get this equation m beta and operator s in this form, like this, by operator s of the submodule of parameter s I j a define the equation 3 equal to the parameter at 0 point plus some factor. The next, we applying the inverse submodule transform on the both sides of equation 3. We will get this equation by s of t equal to s0 plus the inverse of s of submodule, and many parameter s, I, j, and a defined like this. So from the last equation, we will get the iteration s, I, j, and a in the n plus 1 equal to n plus the factor of n defined like equation 4. And the last, the solution is provided by the iteration of limit of s n by n equal to infinity. We will get the solution of s, I, j, and parameter a. Okay, this all of this is the main result. So thank you for your attention, our group. Thank you.